very good morning, good afternoon, good evening to all the candidates and the participants and my dear friends for this NPTEL MOOC course, title of which is Application on Forecasting, Regression and Time Series Models. And my good name is Raghunandan Sengupta from the IME department at IIT Kanpur. So, the three broad areas of coverage for this course of 60 lectures, 30 hours. So, the first one is averaging and forecasting technique, second one is regression, third one is time series. And we are in the second set, which is basically the idea of regression. Even though it is written multiple linear regression, it is regression and we will consider a few more models. So, this is week 6 class number or lecture number 28. So, what is the coverage? Yeah, if you remember in the last lecture, we did one problem in simple linear regression with just giving the formulas. So, there was some typo errors, I have updated that. So, I will keep using that set of slides repeatedly for before each example. So, there is continuity in the discussion and I do not have to basically go back to the slides and again move forward. So, there is no confusion. So, we will today consider other few more examples of regression and that is more in the area of simple linear regression. So, the formulas were, I will just repeat. So, what the main idea is that you want to minimize the error and the error is basically given by the concept error square, sum of the error square. So, the error is basically the actual value where I am putting a red tick mark yi's, all the actual values from I is equal to 1 to n, and the predicted values actually is where I will use the green color is this part, which is basically the intercept, obviously with a minus because you are subtracting that beta hat, and that we have to find out, beta hat we have to find out, minus beta 1 into xi, I is equal to 1 to n, and that difference you square. So, that is the error which has been written down here, which I will mark with the blue color. This is the error, and you want to minimize that error with respect to the parameters which are unknown. What are the parameters which are unknown? It is the intercept, which is beta naught, and the this regression coefficient for x, the only one independent variable which is x, that is given by beta 1. And as you find it out, once you differentiate, put to zeros, and given these two unknowns, you have two equations. When you solve them, the estimated values of beta naught, which is given by beta naught hat, and beta 1, which is given by beta 1 hat, is found out. So, for the second equation, which is given that you minimize the sum of the squares of the error with respect to beta 1, put it to 0. So, I will use the violet color here. This is the second equation, that is why I put 2 tick marks. This is the first equation where I put 1 tick mark. When you basically put it to 0 and if partially differentiate it, you get 2 equations. Those were not included in that initial slide, but I have included them. So, when you read it, you will understand. Obviously, during the discussion, I did mention that we are not going to go into the detailed calculation, but problem solving is important. So, the basic idea should be discussed. So, once we partially differentiate, this is equation 1 where I put 1 red tick mark, this is equation 2 where I put 2 tick marks. When you solve it, so basically you will be getting the formulas which will be utilized here. So, the formulas would be utilized accordingly. Now, once you have that, so basically from that you will be able to find out. So, once you have that, I am going to utilize it to solve the example number 20. Consider the example below where mass is the independent variable y, which is grams of a chemical, which is related to some chemical reaction, and the time for the chemical reaction is given in seconds, which is x, which is the independent variable. So, the problem is where the chemical reaction has been taking place according to the tables based on some time concept. So, the data set is very small. So, you have time x axis which is given in the first column, and the mass, or which is y, which is the dependent variable, which is given in the second column. I mark them. So, say for example, if you see, so the number of data points which would be this. So, this would be basically y 1, which is 7, y 2 would be 9, y 3 would be 14, y 4 will be 18, and y 5 will be 22. The corresponding values of x would be, x 1 would be 44, x 2 would be 124, x 3 would be 184, x 4 would be 214, and x 5 would be 244. So, given this data set, which means technically that n is equal to 5. So, based on that we will solve it. So, we need to find out, so as was mentioned, we need to find out the value of beta naught hat and beta 1 hat, which are the estimates, corresponding estimates of beta naught and beta 1 for the simple linear regression and the regression equation. So, as just shown in the last slide, there are 5 data points with corresponding values to y 1 to y 5 and x 1 to x 5. Now, the idea is that what we need to find, I am just repeating it, we need to find out, I will just put the tick mark here with the different colors. So, I need to find out beta naught hat, which is the corresponding estimate of beta naught. I need to find out beta 1 hat, which is the corresponding estimate of beta 1, because the actual equation for the regression model is this, which is y 1 is equal to beta naught plus beta 1 plus x 1 plus epsilon 1, which is the first reading, and epsilon 1 is the error for the first reading. Similarly, you will have y 2 is equal to beta naught plus beta 1 plus x 2 plus epsilon 2, where epsilon 2 is the error corresponding to the second reading. And finally, as you go, you have the fifth reading, which is y 5 is equal to beta naught plus beta 1 plus into x 5 plus epsilon 5, where epsilon 5 is the error for the fifth term. Now, what we need to do, as we have already seen, we need to basically minimize the sum of the squares of the errors. That means, we need to add up the squares of the errors starting from epsilon 1 square to epsilon 5 square, sum them up and minimize with respect to beta naught and beta 1. So, there are two equations, solve them and you will get. So, once you do that, so the formulas are given here. So, x bar is the average value of x for all the 5 readings. So, here you have y bar is the average value of y for all the 5 readings, and correspondingly you will have beta 1 hat, which is for beta 1, and you will also have basically beta naught hat, which is for beta naught. So, here is the data set. So, if you, even though it is shown here, let me go back and solve the problem. So, I will discard this, copy these values. So, I will open the Excel sheet and I will write it chemical reaction. This is the chemical reaction problem, and as we are following the scheme, I will mark it with blue, just wait. Yes, so the coloring scheme remains. So, you have basically x and y. So, x is given in column A, y is given in column B. So, we need to copy the data. So, the data set is this. So, I will open the notepad and then copy paste, and then from there copy. So, anyway, I will just copy it. This is a small data set that should not be, which is 7, 9, 14, 18, 22, 7, 9, then you have 14, 18, 22. So, 5 data points. Again, let us check. So, there should not be an error in copying. 7, 9, 14, 18, 22. So, you have 7, 9, 14, 18, 22. So, that is done. For y values are 44, 124, the next value is 184, the fourth value is 214 and the last value is 244. So, we have the data set. Just before I solve, let us just plot and keep the data. So, this is x and y. I will go to I am using just simple Excel sheet. So, this is the data point. So, I will mark it as the chemical reaction. Graph. This is the plot, not the graph. Graph would be plot and simple linear regression graph. So, this is done. So, because I am saving it, so let us save it with all the informations being there. So, now I will see that. So, I can reduce the x axis because it is basically more than 5 and less than 20. So, I can keep it between 6 to 23. So, I can keep it between. So, I can keep it 6 to 22. So, the x axis is taken care. And for the y axis, the values are 40 between 40 to 250 I can keep. So, I can keep from 40 to 250. Done. So, I have these 5 data points. Now, I will plot the regression line and then, so I will add the trend line, linear. So, I will add the display, let me display the equation first and also display the intercept. So, this I have, I will highlight it and see, for example, use the color red. So, this is the equation, we will solve it, do not worry. And I will use the color red here and increase the width. So, this is the best fit line and the points are shown in blue, which I will also mark in red, and their width I will also make it a little bit large, like 5. So, this is the basically the equation. So, you have points given, which is 744, the next point is 9,124. The first value I am talking is the x value. The third one is basically 14,184. The fourth one is basically given as 18,214 and the last one is given as 22,244. Now, I will save this and let it be here, and so we will solve it now. So, we will go back to the Excel sheet. So, the formula required would be, we will be utilizing this. Where is it? Yes, this is the main one. So, you need to find out one by one. So, I will just mark it accordingly. So, I need to find out x I into y I, sum them up. Then I need to find out x1 square of x1 summed up. So, I will go by 1. So, here I will write x square. So, x square is the value. So, we find out x square. Next, I need to find out x into y. So, that would be column A into column B, while x square, which is being written in column C, is the values of A multiplied by itself, column A multiplied by column A, the corresponding cells. So, I will also mark them in blue. So, the heading is given, I will bold it. This also I will make a bold. chemical reaction is also bold. Done. Now, I will shift it to the right a little bit. So, what things I need? In the formula, I need summation of xi into yi. So, I will basically first find out sum of xi into yi is given. So, this I will mark with a different color, because these values will be utilizing. So, let us use light blue, green. The next value I will be using the summation of xi's into summation of yi's. So, I will basically find out the sum of all x, sum of all y, and I need to utilize this, which is 70 into 810. This is the second value. Again, I will mark in green. So, this I have found out, and that has to be divided by n. So, I will divide it by n, which is 5. So, it is written here. So, and in the denominator of beta I, you have summation of xi square. So, summation of xi square is this. So, this is equal to sum of xi square. So, there are 5 values. So, I am double checking. So, there is no error. So, that will also be green, but because we are utilizing it. Then you have sum of xi, that is whole square. Sum of xi, that is whole square, is already here. So, this will also be utilized. So, this is also green. So, that should be divided by n. So, let us also divide it by n already. N is 5. Done. So, now we will basically utilizing to find out beta 1 hat, and we will use beta naught hat. So, I will write these values here. So, beta 1 hat is equal to summation of xi into yi is equal to summation of xi into yi. So, xi into yi, let me double check. So, this was basically yes. So, it is equal to the value in cell number D259, which is the sum of all x into y, that is done 5 times because we have 5 readings, minus the value which is basically summation of xi into summation of yi divided by 5. So, this is done. So, this is the numerator, and in the denominator you have xi whole square, which is this, minus this. So, this is the value of beta 1 hat, and very interestingly, I will mark it with, say for example, color should be somewhat, let me use pink. So, this pink value which you see is matching with the value which is given here, which we just found out. The Excel was doing the calculation. So, that takes care of beta 1 hat, and I need to find out now beta naught hat. Beta naught hat is equal to y bar minus beta 1 into x bar. So, y bar would be okay. We have not found out y bar. So, let me find out y bar. Y bar is sum we have found out. So, that would be divided by 5. So, it will be y bar is 110 by 5, that minus you have beta 1 hat into x bar. Beta 1 hat is what? Beta 1 hat we already found out, into x bar is basically this value, total sum of x's is 70 divided by 5, that will be given by minus 8 point. So, let me remove because that dot is not coming. Yes, now it makes sense. Let me check, take it here. Yes, done. So this, and if you see this value, this should also be made pink. And if I check this value, minus 8.91, this is the value which you already have. So this is the best fit line which you have found out. Now another thing, maybe if you find out the trend line, there are many trend lines here: exponential, logarithmic, polynomial, power, moving average. This moving average concept we have already done, but I didn't use this in Excel because I wanted to go step by step and solve the problem. So if you use the latest Excel, once you are aware what is going inside the Excel, be aware and then only utilize it. So the calculations was shown for the chemical reaction problem. So I will move this graph a little bit here. So the part is taken care. So this is the first problem, the second problem solved for simple linear regression. Now I have solved it, so I'll just this is the problem which we are solving. You find out values of x bar, which is sum of x divided by n. So you have x bar, I am putting 1 tick mark. You find out y bar, I am putting 2 tick marks, and based on that you find out beta, first beta 1 hat where I am putting green 1 tick mark, then you find out beta naught hat where I am putting 2 tick marks. These calculations we have already done using Excel. So this is the table which we had, because the formulas which you see in blue color are not different. There I have done it in details in this PPT slide. So whatever was done in Excel is just basically a more elaborate way. So you can find out all these things. So if you remember the formulas are not different, again I am mentioning. So based on that I find out x bar, y bar, beta 1 hat, beta naught hat, and the values come out to be for beta 1 hat as plus 12.206 and for minus beta naught hat is minus 8.91. So this values which you have already seen are here. Here it you see 12.20 is 12.20. You have minus 8.91, minus 8.91. So I am just not going to the third places of decimal, that is not that important, but main thing you should get the idea how the problem is solved. So this is the problem of the simple linear regression of mass versus time, the chemical reaction. Same question, only that in the Excel sheet if you see, I have basically kept the Excel the x axis limited between 6 to 24 and y axis accordingly. By the way, you are seeing a term here which I will mark in violet, this r square, this is important and I will come to that most probably when I am doing the multiple linear regression, because in the simple linear regression the concept of r square, adjusted r square would not make much immediate give you information, but r square or adjusted r square, when you solve the problem people will ask in general details that what is the value of r square, what is the value of adjusted r square, why are the values too different. So those things I will come when I am going to the multiple linear regression concept, because why I am saying that in multiple linear regression you have more than one x, because here there was only one x as the independent variable. In multiple linear regression you will have more than one x. Say for example, if x is 3, so you have random variables x1, x2, x3 each with n number of readings. Similarly, y would also have n number of readings. So utilizing x1, x2, x3, you will basically have the data and try to find out, considering there is an intercept, there you will find out beta naught hat, then you will find out the corresponding regression coefficient for x1 will be beta 1 hat, for x2 it will be beta 2 hat, and for x3 it will be beta 3 hat. So once, and obviously if there are 4 unknowns, beta 1 hat, beta 2 hat, beta 3 hat, beta 4 hat with the corresponding hat the estimated values, you will have 4 equations. So, once you utilize and that you will basically have the concept of R square and adjust as R square, and I am saying I will come to that in details using a few simple problems. Now, the idea of the corresponding fact that in the simple linear regression, maybe the line is in the first quadrant increasing, maybe the line is in the first quadrant decreasing, maybe the line in the first quadrant there is no change. So, first quadrant I am saying that it may be in the second quadrant also, third quadrant also, fourth quadrant also. But here I have just plotted the graphs, because if you remember in both the problems, both x and y values were coming out to be positive. Now, if I want to understand the relationship, because that concept of beta, if you remember, in some case it can be negative, some cases it is positive. The idea would basically be that if beta, corresponding beta values, whatever the x values are, if it is positive, it means that the rate of change of y is being positively dictated by x. That means, for increase in x, y will also increase, for a decrease in x, y will also decrease. If the regression coefficient has the values of negative, it means for increase in x, y will decrease, for a decrease in x, y will increase. Now, this would basically mean that the corresponding beta values would be calculated as positive and negative. So, if I see the graph here, in the first one, on the left panel you have all the values, even though they have been drawn in the first quadrant or second quadrant, that is immaterial, but it is increasing. So, positive. So, if I consider this, the theta angle or the best fit, that tan theta is positive. And if you have basically in the in the case when it is decreasing, as here, let me use a different color. So, if it is decreasing, so in that case it is a negative trend, and in case if it is has all the values scattered, you will basically have the relationship as almost 0. So, if I go back to the basic concept of correlation coefficient, in the case of correlation coefficient, when it is shown as violet, correlation coefficient would be positive. If I go for the case of the second panel diagram, correlation coefficient would be negative, and if I go back to the third panel diagram, correlation coefficient would be almost 0. Now, we all know the values of the correlation coefficient are always between -1 to +1, and we will be utilizing that in a very simple way later on. So, with this I will end this class and continue more discussion about simple linear regression model, and then multiple linear regression models, problems, then come to the concept of R square, adjusted R square, and few concept of ANOVA table. ANOVA table is basically analysis of variance, which obviously many one of you would have done in statistics, but it will be important as we handle the problems of simple linear regression and multiple linear regression. So, have a nice day and thank you very much for your attention.